Good afternoon, everyone. My name is José Centeno, and it is a great pleasure to be here with you at this fourth International Student Conference on Medical Geology and Environmental Health. I would like to take the opportunity of this presentation to express my personal appreciation and congratulations to Professor Kirti Kumar Randive and also to Mr. Pratek Godboil for their amazing and remarkable leadership in organizing this unique conference. Uh, I has been asked to talk to you today about the our discipline of medical geology and kind of describe some of the what we take as the origins and the present contributions and the future of our discipline. The title, initial title that I selected was the emergence or the emergent discipline of medical geology. And probably I should basically probably correct this title by just adding that the re-emerging discipline of medical geology. Medical geology is not actually an emerging discipline; it's a re-emerging discipline that has been with us for centuries. And during this presentation, I will demonstrate to you what I mean by that. Some of the history that provides us with the initial beginnings of our discipline. And what is the difference between what was at that time and what we are doing today in our discipline of medical geology. So I'm going to start the presentation. And I wanted to also describe to you very briefly that during the third International Student Conference on Medical Geology and Environmental Health, I had also the privilege of being invited to give a talk about medical geology. Uh, and at that time, my talk was dedicated to look at the integration, providing a pathway for integration between the geosciences and public health. And so we focused that at that time the discussion in that particular objective. So today I'm going to uh, chat with you and share with you some of our thoughts about the origins, the recent advances, and the future of our discipline of medical geology. Before going into all the different discussions, I want to emphasize a couple of things. Um, I am one of the co-founders of members of our International Medical Geology Association, as well as what we call modern medical geology. But together with two of my other dear friends and colleagues and brothers in medical geology, uh, we have been working for the last probably 30 years in developing this re-emerging area of medical geology. And I have to mention here my colleagues, my dear friend Ulla Salinas from Sweden. Ulla is an exploration geologist from the Geological Survey of Sweden. And Ulle, he passed away uh, uh, last year, but he led a legacy of of the development of medical geology as one of the co-founding fathers of our association and our discipline. A dedicated, hardworking medical geologist that dedicated his life to this re-emerging discipline of medical geology. And also my dear friend and colleague, Robert Bob Finkelman, who also Bob is a geologist, as you probably all of you know. And Bob and I and Willis worked together for many, many years in developing our discipline of medical geology. Uh, Bob is also a geologist, and he area of work is on the studies of coal and how the coal has been studied as one of the geologic factors that have influenced human health as well. So myself, I am a toxicologist. I am a physical chemist by training and by professional background. I am a toxicologist who has worked, I have worked in the area of chemical toxicology, chemical pathology, and also environmental toxicology. Excuse me. So I bring together more of the public health perspective to the area of medical geology. Now, as in our association, the International Medical Geology Association, we have two events that really are unique for to spread the message of medical geology. One of them is this conference, the student conference on medical geology and environmental health, developed a few years ago, and it has been going very strong for our dear students that are coming into this discipline of medical geology. But also we have the association have what we call the International um, Medical Geology Conference, which is a conference series that was developed back in 2005 and is organized every 2 years. And here in this slide, you can see all the different countries where this conference has been developed since 2005. The last one was this year, 2025, and it was in Portugal, in the beautiful city of Aveiro, at the University of Aveiro, and it was organized by our colleagues and friends, Professor Eduardo de Silva Figueiredo, and also by Dr. Carla Pantija. It was a fabulous conference that they had the opportunity, they gave us the opportunity to come and discuss different aspects of medical geology globally. And for your information, the next one it will be in Brazil in 2027. So based on the efforts that we have developed in our International Medical Geology Association, we have also, I need to mention to you that the development of this discipline has been a contribution not only from Ule, Bob, and myself, but it has been a contribution from colleagues from all over the world that have contributed by developing research projects, by leading workshops and conferences regionally or nationally or internationally, and doing preparing also capacity building courses and conference as well. So this is a very short, kind of a short list of all our colleagues across the globe who has been working on the area of medical geology. This list by no means is complete. We do have, there are many colleagues that, because of this pace of this slide, I was not able to include them here, but there are many, many others across the globe that has continued to develop and contribute to the development of medical geology. Today, as I mentioned during the introduction, I'm going to talk to you about the origins, what we takes as the origins of our discipline, the current uh, uh, pathway or the current way in which we actually continue to develop medical geology today, what we call modern medical geology. And then also I would like to talk about some of the key research contributions that geoscientists and public health scientists have brought into this re-emerging area of medical geology today. And I'm going to spike your interest at the end by giving you some thoughts about the future of our discipline. So, what are some of the challenges that we face today, and what are some of the unique opportunities that we have for, particularly for our students, looking at the progression in their professional career, and what are the opportunities that we have today to even explore a professional degree on medical geology. And what are the areas that we consider potential areas for growth, for continue growing our association and our discipline of medical geology. So I always present this slide because I think that this is very important for us to kind of revisit. I know that during the conference you have had the definition of the working definition of what is medical geology. I wanted to kind of emphasize a couple of things here when I bring this slide again to you, to you, and it's that medical geology is as being a re-emerging discipline that looks at the relationship between geologic materials, natural geologic materials, and geologic processes, and their impacts not only in human health but also in animals and plants. Medical geology, the application of our discipline, has the power of medical geology lies in the ability to capture principles and concepts from several allied disciplines and unify them in a single place, thus providing a more holistic approach to disease diagnosis and therapy. So this is the essence and what I call the uniqueness of our discipline, in which we bring together several disciplines to discuss and to work together for the better, the well-being of our society and human health. Um, the This particular definition was put together by our dear friend, uh, Professor Theo Davis. Is Theo is one of the pioneer medical geologists in Africa who has studied extensively the area of medical geology as applied to the African continent, and what are the research projects that has been developed in that area in Africa. Particularly relevant to this conference is the fact that medical geology not only brings together the geology concepts and knowledge, but also brings and public health medical concepts and applications and approaches, but also brings together the the environmental sciences and allowing us to understand more about the the environment, what has to do with human health, and the geologic context of in the environment that we need to integrate as well to make this area of medical geology. Now, by this definition, basically, what it's telling you is that medical geology is a multidisciplinary discipline. Brings together not only this intersection between geology, health, and environmental sciences, but bring together also different areas that to enhance the mission and objectives of medical geology, such as geography, epidemiology, toxicology, pathology, chemistry, biology, social sciences, economics, and the growing issues dealing with climatology, engineering, and even politics. All this brings together what medical geology as a multidisciplinary discipline is. Just to give you a little bit of a historical perspective, and this is when we start to look at why I call this area a re-emerging field or a re-emerging discipline. If we look at the literature, what has been published or mentioned on this re-emerging area of medical geology, we can go back to the 1800s, and it's particularly in the year 1883. If you review the medical and geological literature, you're going to see a series of publications and activities that were used to first mention the term medical geology. For example, in medicine, there was a particular assay or document that was published by, at that time, an anonymous British physician relating medical geology or mentioning medical geology in the practice of medicine in during that particular year of 1883. In geology, one of the events that took place during that time was that there was the U.S. Geological Survey published one of their most impactful reports at that time, which was the fifth annual report that was submitted to the U.S. Secretary of Interior. And the uniqueness of that report was that it gave extensive data and maps that at that time, it was used to describe the geology and the geologic makeup of the regions and in the US. But also it was used later to demonstrate how geologic materials can actually become in contact with human populations in those areas where maps were developed to describe those materials. Today's the U.S. Geological Survey continues to do something similar, in which maps are used to describe or intersect that in that area of understanding the impact of natural materials and environmental factors with human health. Interesting is also that at that time, in 1883, there was the publication of programs looking at what we call today, and as well as that at those times, environmental awareness. And that is basically looking at or demonstrating how the environment has impact the human health and animal health. And at that time, the particular area of environmental awareness was used to illustrate the environmental impacts of resources exploitation at that time. And in addition to that, books and articles were published. You can see in the literature how the articles and books looking at the biogeochemical context and what they call at that time bioelementology, which is basically trace elements, the study of trace elements in human health, uh, appeared during those times as part of a connection with medical geology. And there was a book that described the relationship of physicians with early American geology. This book was published by Dr. Browning, William Browning, an interesting connection between what at that time was the view of geology and human health. In addition to that, if you looked at in terms of promoting the discipline of medical geology, there was a mention of a conference in the 1930, which was organized in Lisbon, in Portugal, and the conference was called the International Congress on Hydrology, Climatology, and Medical Geology. And historians began to look also at the link between the incidence of diseases such as cholera and in regional geologic environments. And our Dr. Harstad, a historian that looked at this issue, at this connection, cite the work of Dr. Jackson and Lapham on this area of looking at cholera. And he mentioned that Professor Jackson and Lapham were certain that they had founded a new discipline of medical geology, which will attract future scientific investigations. So there was already this kind of approaches in the historic perspective of the development of the medical geology and the term medical geology. So, but the origins of medical geology from the it goes even way back when you looked more about the contributions of physicians in England over 200 years ago, when there was a growing interest of physicians on the geologic and natural environment. And for example, this is a historical perspective of looking at the use of what some of the elements that are factors in the research medical geology. The modern history of, uh, of the element arsenic can go, for example, back to the 18th century when Sir Withering, who discovered digitalis, was a solution basically to treat different kind of conditions such as dropsy. Um, he began to look at the use of arsenic, uh, very low levels of arsenic, to treat these kind of conditions. And Sir Withering argued that poisons in small doses are best medicines, but that the best medicines in too large doses could be poisonous. And this is one of the principles of medical geology. But medical geology receive a strong contributions and from and development in the 19th century from several physicians, British physicians. And one of the samples that I always like to mention is, for example, the sample of Dr. James Parkinson. Dr. Parkinson was a physician, but he was also a geologist. And one of the uh, contributions that he made to the development of medical geology and to the development of medicine was his account or his uh, study of what he called the paralysis agitants, which we actually recognize today as Parkinson's disease. And what is interesting here is that Dr. Parkinson, when he was looking into this type of condition, he was using, he began to use extracts of a particular plant, which was called is called Macuna. Macuna plant is a plant that the extract of that plant contains levopamina. And levopamina is, we know today that is a precursor of dopamina. Dopamina is a neurotransmitter that is a, in Parkinson's is not is basically not found, and this kind of treatments uh, using these natural extracts allow Dr. Parkinson to understand a little bit more about the agitants, the paralysis agitants. What is interesting also is that he didn't know the material contained this neurotransmitter, but today the medical advances allow us to study these neurotransmitters and relay them to this condition that today is called Parkinson's, based on James Parkinson's contributions. But the modern medical geology is what we actually are today. We most of the what you see today has been based on. And in a sense, the area of modern medical geology has to do more with today with the uh, the support that the discipline has received from institutions, organizations, and even scientific organizations such as the Swedish Academy of Science, the US Academy of Sciences, and many other organizations that has began to look into the 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 development of medical geology. So what we call modern medical geology brings together a series of events that have taken place since the early 1990s, from the beginnings of the establishment of the International Union of Geological Science Commission on Geoenvironment. This was an effort that was led by Ulla Salinas in bringing this aspect of this organization interest into the development of medical geology. From the development of short courses, publications such as the book on Essentials of Medical Geology, the establishment of our organization, the the uh, uh, contributions from National Academy of Sciences, and even the development of centers of excellence on medical geology, which have began recently in different regions of the world. So this is what we call medical geology. Is what the when we see the contributions and the interest from organizations uh, that have to do with the development of sciences in different countries around the globe. Um, but in a sense, if I this is something that we also believe or take as the part of the growing of modern medical geology, which is the what we call the birthplace of modern medical geology. This was in the beginning of the 1990s. We began to look into many health issues in China with colleagues from China associated with trace element deficiencies and toxicity. And many of these trace element deficiencies and toxicity have had to do with the deficiency of many of these elements in the natural environment, and also excess concentration of many of the elements like arsenic in the natural environment as well. So, so we began looking at this intersection between the natural environment and human health here in China, in Guizhou province, with our colleagues, our Chinese colleagues. In the photo on the left of this slide, we have our dear colleague Bao Shan, who we consider to be the grandfather of medical geology, because he was the one that brought together these issues to the attention of the growing area of modern medical geology. And so this is what we consider the birthplace of modern medical geology. Based on these developments, there were a, 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 an increase on our activities that have to do with workshops, conference, and short courses of medical geology globally. We gave over more than um, uh, 50 short courses in more than 50 countries during during this period of time when for the development of modern medical geology. Publications, several books were published, and not only our book on medical geology, the book of Essentials of Medical Geology, but there were many, many other publications that were sponsored by organizations such as UNESCO and such as the Swedish Academy of Sciences. The journal Ambio published a complete a, a, a version of their journal dedicated to a conference that was held at the Swedish Academy of Sciences dedicated to medical geology. So there are many, many others publications that have appeared uh, in what we call modern medical geology. The 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 book on Essentials of Medical Geology uh, was actually translated into 4 or 5 languages, and today continue to be one of the textbooks to use for the teaching of medical geology at the schools of public health and many other areas associated with the training and capacity building of medical geology. So what are this was a very short historical perspective of our discipline. So what are some of the key research contributions that geoscientists and public health scientists have done throughout the development of medical geology? So I'm going to take an example basically and give you three of a particular area, and then give you three study cases that outline and emphasize the key contributions of geoscientists and public health scientists towards the development of modern medical geology. Um, the samples I'm going to give you is both looking at the principles that have been applied of environmental geochemistry, first that have been applied to develop research and medical geology, and an understanding of how the geochemical information has been used to protect public health and by in situations in which we find some of these natural contaminants. Particularly, I'm going to focus these three case studies that I'm going to give you on metal contaminants, because this has been one of the most addressed research areas on medical geology. So before going into that, there are a couple of terminologies that geoscientists have developed to integrate that information to medical geology projects. And one of the first terms that was developed was dealing with, for example, with geotoxicology. Geotoxicology is the study of the geological, mineralogical, and geochemical, the solubility, the bioreactivity characteristic of earth materials that may influence their toxicity. This was a particular area of work that was developed by one of our dear friends and colleagues, Dr. Geoffrey Plumley from the U.S. Geological Survey and his research group. And one of the publications that you can actually see the development of this terminology is in Dr. Plumley's publications on medical mineralogy and geochemistry that reviews how this area was developed. Based on that, the term geoavailability. Geoavailability is a term that has been developed by geoscientists to as a contributions to the development of medical geology to discuss that area that studies the portion of metals or metal-bearing compound total content in an earth material that can be released to the surfacial and near surface environment by either mechanical, chemical, or biological processes. Basically, what this definition is telling you is that in order for a metal or metal-bearing compound in an earth material to be bioaccessible and bioavailable, and bioaccessible and bioavailable are two terms that are used in toxicology. In order for a material to be considered to be bioaccessible and bioavailable and to have impact human health, it must be first geoavailable. So if the element is not geoavailable in this natural environment, it's not a threat to human health. That's what basically geoavailability terminology means. Now, from the toxicology, public health point of view, this is very important, this continuum of connecting the geoavailability with bioavailability and bioaccessibility is very important because that allows to describe, for example, the two type of fractions, the geoavailable fraction of a metal or metal compound that may be soluble in various body fluids, such as the blood, the gastrointestinal or respiratory or perspiration type of biological systems. But there's a difference in toxicology between bioaccessible and bioavailable. Bioavailable is more that part of a contaminant or a material that may be absorbed by the body and be mobilized or transported within the body to a site of toxicological action, such as the liver, kidney, or other type of organs. So what I'm trying to translate here for you is that to be able to understand the bioaccessible fraction and bioavailable fraction in toxicology and human health, when we looked at natural geologic materials or natural geologic processes, we need to understand first the geoavailability of those type of materials. And this to determine the geoavailability, there has been many laboratory in vitro type of testing done to look at that kind of behavior of materials in the natural environment. So this terminology has been used by geoscientists and public health to study or to assess the global impact, for example, of heavy metal pollution. And the elements that we have focused on, for the most part, has been, for example, arsenic, cadmium, lead, mercury, and other type of toxic elements that are not essential elements for human health, to preserve or to the benefit of human health. These elements are toxic, so in the natural environment, they can actually be seen in the natural or been detected in the natural environment. So the geoscientists and public health have developed research projects to address the global impacts of heavy metal pollution. And for example, one of the case studies that has been used is looking at the bioaccessibility based on the geo availability studies of lead from earth materials. And the sample that I can give you is one research project in Zambia, where there was a lead population that was exposed to lead in the environment from mining practices. And in this particular case, geoscientists study the geoavailability of lead, and it was linked with the bio monitoring of blood lead in populations exposed in this area to determine the risk to human health. And there was a direct relationship between the geoavailability of lead in the soils contaminated with lead versus blood lead levels in the population. This is a still ongoing project, which is now addressing how to reduce or mobilize or remove the lead from these areas contaminated with that element. But in addition to that, second case that I can, research case that I can give you is looking at, for example, the metalloid arsenic. This is an element that we know for its toxicity and the impact to human health in different ways. Not only is a cancer-induced element, but also induces different type of systemic conditions such as diabetes, peripheral vascular diseases, and even fibrosis of the liver. So this is a very important element to study in medical geology. And geologists have used many approaches to look at the geochemistry of arsenic in soils and contaminated drinking water. Uh, Public health scientists, on the other hand, have used as geochemical information to link that to the speciation of arsenic in human health. And so it's very important to make that link, because the speciation studies are critical to know what are the species of arsenic that we may be exposed to, develop accurate toxicological evaluation, and to as well as bioaccessibility studies, and eventually to do risk assessment studies. Finally, the last example that I want to give you in this particular area of contributions of geoscientists and medical and public health scientists to medical geology is the study of atmospheric dust. There is a lot of work that has been published on the mineralogy and geochemical characteristic of, for example, volcanic ash and many other type of global mobility transport of atmospheric dust. The areas that are beginning to be more applied and as part of the interdisciplinary medical geology research is looking also at what are the toxins that these materials, this atmospheric dust, may carry, and through their as they travel through regions. And in this particular case, many of our medical geologists have been able to look at the characterization, the inorganic characterization of the dust, and they have demonstrated that there are toxic elements such as chromium, copper, zinc, many others that may be mobilized by the dust. But a growing area of research is also looking at pathogens, microbes that may be mobilized by the dust. So this kind of toxicological, geochemical information, as well as microbiological uh, and information, is very key to link to these studies, uh, as as we uh, as we looked at the impact of atmospheric dust in human health. In fact, want to mention to you that there is a conference that came actually out of our International Medical Geology Association as well, and it's the dust conference, or the atmospheric dust conference, that is held every 3 years. And the conference is held in Bari, Italy, and is organized by one of our medical geologists in Italy. His name is Professor Saverio Fiore, and Saverio has um, taken this particular area of research uh, to uh, bring together scientists into this conference to discuss the research advances on dust, atmospheric dust. So, but from the toxicological and public health perspective, there is still, when you consider dust-related materials, there is still a lack of understanding on many areas that we need to continue working and optimizing our research. Understanding the function of the pathway of exposure, the intensity and duration of this dust that is being mobilized intercontinentally, um, even the specifics about the particle mineralogy, the shape, the chemical composition, the surface freshness, the morphology of the particles, that may affect or influence the solubilities, the chemical reactivities upon contact with body fluids that are encountered during the exposure pathways. And very important is also to study the chemical form, the speciation of potential toxicants that may be mobilized by earth materials and dust, and that may become in contact with the body fluids. For example, there has been many publications about the inorganic composition of dust, and some of this dust that travels regions are developed in regions that are very arid or semi-arid. Um, there have been publications that have shown the presence of, for example, chromium is 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 important for the toxicologists and for the public health scientists to understand what is the form of chromium in this particular type of dust-related materials, so that we can address the health impact. Um, if it's chromium 3 or chromium 6 in terms of the chemical state, it's very important to understand its chemical speciation so we can address its toxicity, as well as understanding other factors such as absorption, distribution, metabolism, elimination of the toxic material, and the personal factors as well, diet, smoking, and other environmental exposures. So this is the kind of research that we still are not uh, well, has not been still well developed to understand the health impacts of those related materials. Finally, I would like to take a few minutes to give you some thoughts about a glance to the future. What are the challenges that we may face in the future? What are the opportunities that we have available to us, and particularly for our students that are coming into this area of medical geology? Um, Areas of concerns for addressing in terms of public health issues and the impact of natural materials and their and natural processes. Areas of modern global concern continues to be, for example, the quality of water, drinking water, the quality, and the presence of geogenic pollutants such as fluoride, arsenic, lead, and even mercury. Climate change is continuing to be uh, an area of significant growing concern uh, in public health and of course from geosciences and medical geology. Atmospheric dust and the study is still the exposure to mineral dust, such as mineral fibers that we may find in the natural environment, asbestos, um, irianite, and others. And what are the risks of exposure to this type of materials? Studies have been published, for example, in Turkey about the exposure to fibers such as irianite and health issues associated with that exposure. But very specifically, the uh, medical geology developments on veterinary medical geology, urban medical geology, as we look at the development of cities and the topic of healthy cities, what kind of decisions or approaches needs to be put into place to look at the impact of urban medical geology. medical geology and mental health, occupational health is an area of that perhaps is not entirely related to the medical geology as we looked at by the definition as natural factors and natural processes, but it's a growing uh, concern that we need to consider when we look at the environmental health part of, for example, of this conference or the development of how to use medical geology tools to understand occupational health. And an area that I think is very is getting more and more attention because of the widespread uh, needs is understanding more about the non-communicable diseases and the link with medical geology. When I say non-communicable diseases, I refer to areas, the growing concern about cardiovascular diseases, the growing concern about diabetes, and many the respiratory conditions. Uh, all that kind of conditions, there is a strong need to see the natural environment, for example, mining practices, how the mining practices have impact the development of non-communicable diseases in regions such as in Africa. One of our colleagues working in this area of non-communicable diseases is Professor Emmanuel Arguin from Ghana. And Emmanuel has been doing unique research in understanding the impact of mining practices in the development of non-communicable diseases. And also understanding the interactions, the mechanism of interactions, what kind of molecular or cellular type of interactions have to be studied when you look at the interaction with natural earth materials. One area of development and opportunity to look at these needs or these new areas of concerns is the development of what we call today risk assessment health maps. And in this particular slide, I show you a great example of how this risk assessment health maps has been developed to look at the study of non-communicable diseases, for example, in the Slovak Republic. Our dear friend and colleague, Stanislav Rapant, and his research group has been studying the composition, the natural trace element composition of soils, and the geochemistry of soils, and the link of that kind of data with the development of conditions such as diabetes, cardiovascular diseases in the Slovak Republic. And they have been able to use this map to look at areas that are susceptible to this kind of non-communicable diseases in the Slovak Republic. So by linking that information with these risk maps, give a way for the public health community to have an action, how to action develop action activities to protect public health and study that those regions that are susceptible to those type of conditions. What are the proposed science priorities and future opportunities? And I wanted to bring this to particularly to our students because you are your research will help us in understanding how these areas could be developed and continue to be used to protect public health. For example, from there's science needs in addressing emerging areas in public health when you consider the newly emerging pathogens that and for example, the recent COVID pandemic, um, that was a newly emerging pathogen that we needed to be discussed or understood. So public health measurements could have been taken or be taken to protect public health. Re-emerging diseases such as malaria. There are areas where re-emerging diseases have been described, for example, in the Amazon region, where there is a very strong deforestation going on, and some of the habitat uh, for the vector of the malaria has been seen to re-emerged in those modified conditions. Um, the development of advanced tests and methods, the is particularly in vitro bioaccessibility studies have been used to look at the what we call before the bioaccessibility of materials from, let's say, soil chemistry, um, uh, from mining waste. Um, the in vitro testing may have to do with simulated stomach fluid, simulated organ fluids and enzymes that may be used to determine the the retention of materials from those geologic matrices. Characterization, predicting and monitoring impact of medical geology risk factors and air materials in human and animal diseases. And linked to more of the advanced developments are the needs for the develop of novel tools such as spatial analysis, risk assessment, health maps, as I mentioned before, for and analytical approaches such as computational modeling technologies, which will help us to support medical geology decision making. Finally, one of the areas that this is I consider opportunities for growing our discipline of medical geology, as well as uh, uh, helping our students with as they continue working in uh, getting their professional degrees on medical geology is the development of research centers of excellence. And there is one research center of excellence that was recently developed in Nigeria, Nasarawa State University, which was developed with the purpose of sharing scientific knowledge, ideas, and innovations in the emerging field of medical geology, and to research and investigate links between the natural geogenic environment and health. Um, the center is aimed as serving as a training facility for students pursuing their master or doctorate degree in medical geology and to promote the field of medical geology throughout Africa. This is the first center that has been set up uh, to um, to growth or to implement a capacity building um, facilities for medical geology. The actual center offers professional postgraduate diploma in medical geology, master as well as Doctor of Philosophy in medical geology. And the good news is that this center actually is already operational. About this last uh, August, we initiated the first entering class of students pursuing either their master or their doctor of philosophy on medical geology. We initiated actually 25 students began their studies in medical geology as at this center. So for our students, these kind of centers are becoming the trend for the development of capacity building. And if you want to look into more of these centers, there we are aiming to develop centers in South America, also in the Caribbean and in other areas where medical geology uh, is growing academically. So with that, I would like to uh, uh, complete this presentation. Just I would like to again thank you, the organizers of our fourth International Student Conference on Medical Geology and Environmental Health, uh, Kirti, Kumar, and Pratek. You have done a fantastic job with this conference. And, and I would like to also extend my gratitude and my appreciation and congratulations to all our students presenting at this conference. Your research is powerful, your research is impactful, and your research is making a big difference in in South Asia, but in addition to other areas where this conference students will be looking at this what is being presented at this conference. So congratulations to you all for what you bring to this conference and for the work that you have done uh, to um, to implement and to develop medical geology. Thank you, everyone. Have a productive day and a very exciting conference. And I apologized that I am not there with you, that I'm not there with you in remotely right now. Uh, Due to previous commitments, I have to be on travel this particular week, but but I wish you great success and a great conference. So thank you so much for having me.